My name is Dr. Sammy. I'm going to be your maths tutor for today. I'll be teaching you differentiation. Now, this is a very, very important and vital topic for any student doing UTME. And then you know your exam is at hand. So that's why I'm uploading this video. So, if you are just visiting my channel for the first time, you are going to do 3 things for me. Kindly hit the notification bell and then hit the notification button with the subscription button so that anytime we upload any useful educational video you won't miss out. So we'll be doing differentiation today. Now, what is differentiation? Differentiation is also called slope. Differentiation is also called what? Slope. Let me put equal to, so that if differentiation is still same thing as slope. Now in your secondary school, what's the formula for slope? Now you have been taught that formula for slope is change in y over change in x. So what is change in y? Change in y is x2 minus x1 over what? Y2 minus y1 over x2 minus x1. So therefore, differentiation also is what? Change in y over change in x. That's why we call differentiation the y over what? The x. Differentiation of slope. So that's the first thing. Now I will show you another page again about what? Differentiation. Now today what I'm going to be teaching you is how to differentiate from the first principle. Differentiation from first principle. From first principle. So this is very, very easy. Now I will derive the formula quickly. So because y equals to fx, equation 1. What do I mean by y is equals to fx? Now equation can be written in 2 ways. You can have equation like this, 3x squared plus 2. Now the heading is what? Y. And now in mathematics, you can also change the heading to what? F of x equals to what? 3x squared plus 2. So if we did not use the heading as y in mathematics, we use it as what? F of x. So therefore, we say that y equals to what? F of x, because the two represent headings of what? Equations. So take note of that. And now you know differentiation is changing y and with respect to what? Changing x. So therefore, let's say changing y applies here. This changing y, f, and changing y, x occur. So that's differentiation. When there's changing y, there will be what? Changing x. That's what? Differentiation. So we call this equation 2. So now what do we do next? Subtract equation 1 from equation 2. Subtract equation 1 from equation 2. Subtract equation 1 from 2. So what do we have to subtract equation 1 from 2 to become? Y plus dy minus y2 plus fs plus dx minus what? Fx. Yes. So if we subtract this equation 1 from 2, that will be y plus dy, remove y, equals to fs plus dx. Subtract 1 from it, equation 1, so it becomes this. So now what do we do next? Y can cancel minus y. So it becomes dy equals to what? Fx plus dx minus f of x. Are we together? Now divide both sides by what? Dx, so that we'll have our what? Dy dx. So divide both sides by dx, we'll have something like this. Now in mathematics and physics, now have you reasoned that if a ball is running, the ball must stop? And then when you are running, you are changing your what? You are changing your distance. The equation is what? Changing. So therefore, there is something about motion. When you move, you must come to rest. So anything changing as change in y occurs due to respect to change in x, they will actually what come to rest with what the effect of time as time goes on. Even though you run, as time goes on, as you change your equation, you come to rest. Therefore, we always say that dy dx equals to limit the x tends to 0, because as the x changes, which will affect the change in y, with time the x what will become what 0. So therefore, it limits the equation to this. We now have fx plus dx minus f of x over what dx. So now this is the what? This is the formula we'll be using for what? Differentiation of the what? First principle. Please let's take note of this formula. It is very, very easy. Now I'm going to solve some examples for us. So have the idea of what I'm saying clearly. So now example 1. Let's say we have x and we have to let's say differentiate x from first principle. So it becomes then you apply this formula dy dx, so that we differentiate the x. Dy dx, let's say this is the equation y equals to x. Differentiate y equals to x from first. So dy dx equals to, now limit the x tends to 0, then f. Now what this means, this f of x plus dx, what it means is that anywhere you see x in the equation you are giving in the question, just what? Add the x to it. So now where did we see x here? So anywhere you see x, just represent it plus with x plus dx. So let me take this so that you get it. Anywhere you see what this x plus dx means is that anywhere you see x in your what? Equation you are giving to differentiate, just represent the x with x plus dx. So now in the equation we are given only one x, so we represent it with x plus dx in bracket. Then minus what? Fx is just everything that is inside the what? Everything is just the whole equation you are given. What's the equation we are given? X. So x over what? Over dx. So now you don't need to put this f again. Since you have I said anywhere you see x, you put what? S plus dx. That is what f of x plus dx is. So now if you have put s plus dx, you don't need to put that f back. So minus s over dx. So dy dx equals to leave dx tends to 0. We are left with s plus dx minus x over what? Dx. So now s can cancel minus x. Then dy dx leave dx tends to 0. Now we are left with dx over dx. Now if you cancel the 2, it will give me what? 1. So the answer is what? 1. The answer is 1. So now let's take another example again, so that we understand this very, very well, so that it is very clear. Now let's take differentiate y equals to s squared from first principle. So now let's say you have to differentiate y equals to s squared from first principle. So it is very simple. The y dx, remember the formula, the x tends to 0, then we have f of x plus dx minus f of x over what? Dx. Just be patient with me, you clearly understand this very well, it's simple. So now let's apply the formula to differentiate the equation we are given. It becomes dx tends to 0. Now I said fx plus dx means that anywhere you see x in the equation, replace it with what? S plus dx. So in this equation we have x squared. So anywhere we see x now, we replace it with what? S plus dx. So in the equation we have x, we replace it with s plus dx. And the s carries square, so the s plus dx will carry what? Square. Minus fx is now all the whole y equation. So therefore, fx will just be, the whole y equation is what? X squared. So fx will be what? X squared over what? Dx. Dx. So now the y dx becomes lim dx tends to 0. Now open this bracket. It is easy to open this bracket. You just say that x raised to the power of 2 become what? X squared. This is the short way. Then the x raised to the power of 2 plus the x squared. Then you will use this 2 to multiply everything in the bracket. Now let's say 2 times x become 2x. 2x times dx become plus 2x dx. Let me take it again. X raised to the power of 2 x squared. Then take this to the power of 2 dx squared plus you use the power to multiply everything in the bracket and you have 2x dx minus x squared over what? Dx. Now take note, x squared can cancel x squared. So therefore, we are left with dy dx lim dx tends to 0. Therefore, we are left with the x squared plus 2x dx over what? Dx. Now, what do? We will simplify this equation, we will bring it down. Like, we will bring the equation down, we will simplify it. So it becomes dy dx lim dx tends to 0. Now, simplifying the equation becomes dx squared plus 2x dx. Now, this division is affecting the 2, so we can separate it from there. As in the denominator is affecting the 2, it's dividing the 2 numerators, so separate for them so that we'll cancel out. This one can cancel the square. Then this dx will cancel what? Dx. So we are left with dy dx equals to lim dx tends to 0. So we have dx plus what? 2x. Now, this dx now, there is nothing we can do again to simplify this equation. So what this dx tends to 0 means is that as the what? X changes, the y will what? Comes to 0. So therefore, this anywhere we see dx now will be what? 0. So it becomes dy dx equals to what? 0 plus 2x. So that's how to apply dx tends to 0. Once you have solved to a place that you cannot further solve again and you have the x, just to represent dx to 0. So this place I can't further solve again, so I represent my dx to what? To as 0. So it becomes 0 plus 2x. 0 plus 2x is still what? 2x. So thank you for watching this video. I believe and hope this video will what? Simplify this topic for you. So kindly what? Subscribe, hit the notification bell. Thank you.